Good evening, everyone. I'm Tom Hand. I'm the president of the Vermont chapter of the American Society of Landscape Architects. And welcome to the fall 2021 Doug Crowell lecture. It's been 2 years since we had our last lecture, which was in person in Burlington. We were pretty close to doing the same this year and welcoming Keith in person, but decided ultimately to host on Zoom, and really happy to have a great turnout from everyone. And thank you all for coming. We're sponsored tonight by Reed Custom Soils. Not only does Reed sponsor the chapter, but they're also the event sponsor for this evening. And then we have additional support from Main Street Landing in Burlington as well. And we're happy to have them. And we have here tonight with us Tony Will and Jeff Toomey from Reed Custom, and we'd love to just have them give a little bit of a brief introduction to Reed Custom and what they do. And this is, specifically geared towards all the designers and landscape architects specifically, but good for general public to know as well that their service is out there.
Thanks very much, Tom. I promise you there will be no overt sales pitch here. What I do want to do is share with you quickly, probably too many slides, but I'll go through them quickly and explain to you all what Reed Custom Soils does. We're the largest supplier of engineered soils in New England. This is what our homepage looks like. And each one of those 8 panels is, if you were to click on it, leads you into more detail about that particular variety of engineered soil. Now, I have not somehow started my slideshow. Oh, there we go. We've learned a lot of lessons by being a major supplier to over 350 golf courses in New England. The USGA really developed the early science on soil studying and soil analysis and techniques for measuring and evaluating soil performance. And we've learned a lot of lessons there, which carry over to the other fields that we sell into. Our parent company is AD Makepeace. They're the largest cranberry growers in New England. They're one of the largest private landowners in New England, and they have access to tremendous reserves of very clean sand, which is perfect for manufacturing engineered soils and top soils and golf course and athletic field materials. This is just an example of a specialty or custom blended soil for a green construction. That would be a very high percentage of sand, like a sports field. So sports fields are a natural extension of our golf business. We supply soils to, including Fenway Park. The soil in the outfield at Fenway Park is 95% sand. So there's, you can have a major rain event and then go right out on the field and play ball because the water drains through it very quickly. We make a variety of baseball infield mixes from collegiate level to little league and professional levels. We dial in different types of contents of clay, depending upon the use. We make lightweight soil for green roofs using expanded shale to reduce the bulk density of the soil. There's project photos from Whole Foods in Lynnfield, Massachusetts. We offer stabilized stone dust, which is an interesting product, much more common in the Southwest of the United States, but we are the major supplier of stabilized stone dust throughout New England. It's a permeable paving option. It's made of stone dust and some natural binders that help hold it together. This is a photo I took 2 days ago at Fort Sewell in Marblehead. On that same day, I went up to the top of Blue Hill, where in early July, we supplied this project with stabilized stone dust. They have a drainage swale in the middle between these 2 elevations. And when you think of the amazing amounts of rain that we have had in the last couple of months, I was up on that job site when it was being installed, and then I went back 2 days ago, and I was delighted to see how really well it had held together. There was no evidence of erosion. This shows some stabilized stone dust being installed using a small sidewalk spreader at the Walden Pond Visitor Center in Concord. These next 3 slides are based on the new Harvard Science and Engineering Center in Boston. This is a rendering of the facility, and then there's a real photo of the actual facility as it's built out. It took years to complete this construction, extremely complicated landscape. There's that bioretention soil in the foreground. There's sort of a sloped grass area in the background, which is actually a landform built on top of foam blocks, just to add some architectural interest to the landscape. From another angle, this is actually a showcase for all of the products that Reed sells. There are green roof sections on that building. There are bioretention, there's stabilized stone dust right in front of us. All sorts of planting bed soils were used at the new Harvard complex, 150 Western Ave in Boston. Really worth visiting if you're in the Boston area. Fiber reinforced soils is the concept of using synthetic fibers, for better or worse, in a planting bed soil to high draining sand-based soil to change the load bearing and shear strength of the soil. These are photos taken of a reverse action tiller, is a type of machinery that can be used to integrate synthetic fibers into the top 3 or 4 inches of a soil profile, which would then be hydroseeded. These photos were taken at Rensselaer Field in Hartford, Connecticut, where they were looking at building over 20 acres of parking, and they elected to do it with turf parking. They just reinforced the soil and they just parked the cars on the grass. Reed Custom Soils is the New England licensed manufacturer of Cornell University structural soil. This is one of the more peculiar soils that we offer, developed by Cornell University probably 30 years ago. It's 80% crushed stone, 20% clay loam that is held onto the stone using a hydrogel as a tackifier or as a glue to hold it on. The competing concept for structural soil is sand-based structural soil. Generally, this is not a proprietary product. There are different designs in different parts of the United States, but this is more of a system where you have to build drainage underneath and an aeration layer on the top. Finally, Reed Custom Soils makes a variety of planting bed soils with these descriptive names, which have become part of the vocabulary of landscape design. Some of them are from Pine and Swallow in Groton, Mass. Some are from other soil science labs, but we manufacture a wide variety of these soils for specific applications. My name is Tony Will. My cell phone number is there. My email address is there. This information is also readily available on the website, reedcustomsoils.com. Jeff Toomey is our Northern New England sales representative. There is his contact information. And I appreciate it. Thank you for the opportunity to host tonight and sponsor tonight's event.
Well, Tony, I can attest to your comment about Fenway, because I went over the summer with my son and my dad, and we had a giant downpour, and 10 minutes later they're out there ready to go. So it works.
Sort of a big hydroponic experiment, really.
Yeah. Well, thank you again for sponsoring, and for both you and Jeff for being here. And I believe, Jeff, you're coming up next week. So if there are any LAs in the state interested in connecting with Jeff and kind of learning more about what Reed Custom does, it'd be a great opportunity to connect. So the reason we're all here tonight is to listen to Keith Bowers, VTASLA, and he is the founder of Biohabitats. And for over 3 decades, Keith has been at the forefront of applied ecology, land conservation, and sustainable design. As the founder and president of Biohabitats, Keith has built a transdisciplinary organization focused on conservation planning, ecological restoration, regenerative design, and integrated water strategies. His work has spanned the scale from site-specific ecosystem restoration projects involving wetland, river, woodland, and coastal habitat restoration to regional watershed management and species conservation planning, to the development of green infrastructure and urban ecology planning for cities and countries around the world. Nature in the full array of life this planet has to offer is at the very core of what Biohabitats is all about. Increasingly, we find ourselves living in an artificial world, a world where ecosystem processes are comprised of and biodiversity is marginalized and commoditized. Nature in its wildest and raw form is at the essence of what Biohabitats does. Wild nature provides the blueprint for ensuring that we know how to conserve, restore, and regenerate the full expression of biological diversity in ecosystem processes that sustain us. It is at the heart of our collective souls and the mission of Biohabitats to restore the earth and inspire ecological stewardship. Biohabitats is a certified B Corp business, a member 1% for the planet, and a signatory to the Earth Charter and Universal Declaration of Rights of Mother Earth, among others. Keith currently serves as a board member of the University of Pennsylvania Ian McHarg Center for Urbanism and Ecology and on the Landscape Architecture Foundation. Previously, Keith served on the board of the Society of Ecological Restoration for more than 10 years and on the board of the Wildlands Network for 6 years. He is a fellow of the American Society of Landscape Architects and a professional wetland scientist. He holds a BS in Landscape Architecture from West Virginia University and an honorary degree from the Conway School of Design. There's some good local props. Keith, thank you so much for being here, for coming, for logging on from warm South Carolina as we're starting to get cozy up here in Vermont.
Yeah, thanks, Tom, and thanks for that great introduction. And thanks, Tony, for sponsoring this event, Reed Custom Soils. I really appreciate that, and I'm honored to be a part of this lecture series, and look forward to a hopefully robust presentation and conversation tonight with all of you. Why don't I see if I can share the screen here? There we go. You have it?
Yes.
Great, fantastic. Although I know next to nothing about technology, seem to have gotten that to work. So yeah, thanks everybody for attending tonight. You may be sitting down, eating dinner, having a glass of wine or a beer or whatever, but I'm excited to be here with you all. So what I wanted to do is start out by sort of recognizing some of the maybe shoulders that I stand on and some of the people that have influenced my career and my life in doing the work that Biohabitats does. And I can't go without mentioning Ian McHarg, which I'm sure most of you, if not all of you, know who Ian McHarg is. Some paths that I crossed with Ian McHarg. I graduated from college back in the early 80s, went through school in the late 70s. I got to actually meet Ian McHarg at that time, and little did I know that growing up in just north of Baltimore in the valleys, Green Spring and Worthington valleys, that Ian McHarg, some of his early pioneering work was a plan for the valleys in the mid 60s. And so that's where I grew up. I sort of played in that neighborhood, went to school there, and was really interested to find out that Ian had a major influence on how those valleys were planned and developed over the years. And so it's just funny how things come back around. But the whole idea of design with nature, the whole idea of thinking about ecology and the environment as a foundation for everything that we do really stuck with me, and stuck sort of to the core of, as I was going through school and learning about landscape architecture and learning about design, the whole idea of thinking about how to apply ecology back to the landscape was something sort of in the forefront of my mind. The other big person that influenced my work was Dr. Edgar Garbish. And Dr. Garbish was considered one of the pioneers in ecological restoration. He was a professor at the University of Minnesota in chemistry, took a sabbatical, came down to the Eastern Shore of Maryland, to one of his family's residence down there, only planning on staying for a couple years, but fell in love with the Chesapeake Bay and the salt marshes of the bay, and decided that he wanted to change his career and figure out how to begin restoring the marshes that were being lost in the Chesapeake Bay, the tidal marshes, the Spartina alterniflora and Spartina patens and the bulrushes. And so he dedicated his life to figuring out how to collect, propagate, grow, and plant and restore wetlands. And I came upon Dr. Garbish and the NGO he set up, Environmental Concern, back when I was in high school, in my early years in college, and thought that's pretty cool. Somebody out there is actually looking at restoring the environment, and doing it in a way where he's out in the field doing pretty large projects of wetland restoration. So I think both Ian McHarg from a sort of analytical perspective, and certainly Dr. Garbish from a practical applied perspective, really stuck with me as I went through school and thought about what I wanted to do after school, which led me to biohabitats. And that was one of the things that after school, after going through college, there was really no firms out there doing the type of work that we were doing. This was in the early 80s. And decided at the time that I was just going to hang a shingle out and start up biohabitats and figure out how to do this work and figure out business. And two things coincided with that decision, luckily for me. One was Maryland passed what is now called the Chesapeake Bay Critical Area legislation, which requires all the jurisdictions around the bay to do essentially what is an overlay zoning district that's adjacent to the bay. And part of that overlay zoning is looking at conservation and habitat. And there was really nobody else out there at the time that was taking that sort of stance. And so we decided we were going to begin offering those kinds of services to those jurisdictions. And then the other thing, the Clean Water Bill was passed in the early 1970s, 72, I believe, through the Nixon administration. But while tidal wetlands were being regulated and enforced, non-tidal wetlands were not being regulated and enforced until the Fish and Wildlife Agency and EPA sued the Corps of Engineers to begin enforcing non-tidal wetlands. And so in the early 80s, there was then a need to do wetland delineations, wetland mitigation, wetland restoration for any impacts to non-tidal wetlands. So I decided that that was also something that we would get into. And my first probably dozen to a dozen and a half hires after I started the business were ecologists, biologists, geomorphologists, soil scientists, all the scientists that we really needed to take the idea of what was happening from a scientific community and the research that they were developing and how to then apply that back to the landscape. So over the years, what's really, I think, where we are now, right, is this whole idea that we've been obviously for the past year and a half dealing with COVID. Hence the reason that I'm sitting in Charleston, South Carolina right now, and you all are up in Vermont. And I would love to visit someday and get up there and be with you all. maybe a recession, maybe not. We don't know if that's looming, but certainly climate change is looming. But I think that what we would argue at Biohabitats that's bigger than all three of these is the collapse of biodiversity. And this is both what keeps us up at night, what gives us the passion for what we're doing, and really sets the sort of course and the rudder for what Biohabitats focuses on and what emphasis we put on projects. This idea of biodiversity. We think that that is going to have much more consequences than even climate change will. And yet it gets comparably very little press compared to climate change. And I think we see that throughout the sort of political discourse and even within ASLA, where there's a lot of emphasis on climate change and carbon, much less so on biodiversity. You know, even the scientists as early as almost 10 years ago were saying that the biodiversity crisis is worse than the climate change, that we're experiencing this rapid loss of species and the rapid degradation of ecosystems, and it's probably a greater threat than global climate change to the stability and prosperous future of humankind on Earth. Now, can any of you tell me what similar characteristics all of these species have? Well, what we know, and a report that just came out about a month ago, is that all these species have gone extinct. These are 8 of 23 species that the Fish and Wildlife Service just recently classified as extinct. And we're seeing a rapid decline in species, both in the type of species and the abundance of species. And worldwide, we're seeing that happen all over. And there's a direct correlation, I think, and it's hard to deny this direct correlation between the number of people on the planet and the extinction rate that's going on. And if you look at the graph on the left, the background extinction rate at the bottom there in that dotted line, and what we're seeing is a huge spike in extinctions of other vertebrate species, mammals, birds, and all types of organisms. And we can directly correlate that to human population. In fact, there was a report put out about 2 years ago that basically said, you know, the world's insects are hurtling down the path to extinction, and according to the best data available, suggesting they could vanish within a century. And many of you may know who E.O. Wilson is, the famed biologist at Harvard, has written a lot of books, has really promoted this idea of half Earth theory, or half Earth, where we really need to conserve and protect half of the Earth's marine and terrestrial ecosystems to make sure we don't have a biodiversity collapse. And I love this quote that he put out many years ago. He said, if all mankind were to disappear, the world would regenerate back to the rich state of equilibrium that existed 10,000 years ago. If insects were to vanish, the environment would collapse into chaos. And we're seeing that actually right now. Unfortunately, we're seeing this sort of silent collapse in insects throughout the world. And it's frightening. It's frightening in terms of what that's going to do over the next 25, 50, 100 years from now in terms of that collapse of insects. So there's 3 things that I think Biohabitats focuses on when we do our work. The first is obviously biodiversity, right? We look at what are the causes of biodiversity, what are the outcomes based on those causes. And I would say that almost all of our work, this is the first and primary thing that we focus on. We look at destruction of habitat. We look at habitat fragmentation, which is probably the #1 cause of the loss of biodiversity. We look at invasive species, pollution, pesticides, extraction, and climate change. And climate change is certainly exacerbating the loss of biodiversity. The other thing that we pay a lot of attention to for obvious reasons is climate change, right? So our work is very much informed by climate change. And I would suggest that when we started back in the early to mid 80s and when we were thinking about ecological restoration, when we knew less about some of the long-term aspects of the loss of keystone and predator species, when we were just beginning to learn about climate change, the idea of ecological restoration, about restoring an ecosystem back to its sort of evolving state, seemed relatively and probably naively simple back then. Fast forward 30 to 40 years later, and it's become really, really complex when we think about ecological restoration. In fact, we don't like to think about restoring the past. Our sort of motto is restoring the future, because we have to think about the future in terms of the adage of going out 7 generations and what's going to happen to our planetary systems, and what do we really mean by ecological restoration when we're trying to restore an ecosystem. And then the other thing that is something that we really try to focus on all our work is environmental justice, right? I think we all know the links between the loss of biodiversity, the climate change, and sort of the pickle we're in, and how that relates back to environmental justice and many systemic causes of environmental justice issues we're just beginning to uncover, and I think come to terms and realize how that's affecting us, how that's affecting our lifestyles, how that's affecting our economy, our social and cultural systems, and certainly our environmental systems. And so I think more so every day, all the work that we're doing, we're looking at biodiversity, we're looking at climate change, and we're looking at environmental justice. So what I thought I would do is take you through some projects that we've had the great fortune to be able to work on. Probably some of these are probably about 2 or 3 years old, but nonetheless, they'll give you an idea of some of the work that we're doing, and hopefully we'll leave some time at the end for some questions and discussions. I'd love to hear what you all are thinking about this and what kinds of projects and dilemmas and conflicts that you're dealing with as well. But first, what I thought I would do is just talk a little bit about this idea of loss of biodiversity. And as I mentioned before, habitat fragmentation is a huge issue, and most scientists believe that that's probably one of the #1 aspects of the loss of biodiversity. When we begin to shrink habitat patches, if we're thinking about this from a landscape ecology perspective, we begin to then compromise the genetic diversity of species that live within that habitat. And if there is no migration in or no migration out of those species, then that genetic pool gets smaller and smaller over a period of time. And pretty soon you begin to lose those types of species. And so as we continually fragment our landscape, whether that's through roads, farming, housing developments, power lines, you name it, we begin to continually cut up those pieces and make them smaller and smaller and smaller. So one of the things that we're constantly looking at when we're doing our work is kind of going back out 30 or 40,000 feet and thinking about how the site that we're tasked to work on is connected or disconnected from the regional landscape. And I would suggest probably that that's probably the #1 thing that we can do as landscape architects is think about connectivity, think about landscape connectivity and how species are going to move, or how are they able to move across the landscape. I think the other thing that we tend to forget, but we're finding out more and more about this, is the loss of what we would call keystone or maybe predator species like the wolf in the east. or the cougar. And when we begin to lose those top predator species, there's this cascading effect that sort of vibrates all the way down through the ecosystem. And there's all kinds of unintended consequences that begin to happen. So even if we're thinking about connectivity and we're thinking about restoring the landscape, if we don't think about restoring some of these top predators or these keystone species, then we're always going to be, basically addressing or dealing with the unintended consequences of not having those species around. And so that just makes ecological restoration and the idea of conservation even more complicated as we move forward. So some of the paradigms that we think about a lot at our practice is sort of, where are we coming from and where do we need to be, right? Where are we coming from? Well, we're coming from this idea that nature exists in equilibrium in order. And where we really need to be is that we need to embrace the idea that nature is chaotic and it's dynamic. And it's, it's constant. Sorry about that. It's constantly evolving. That the idea that, everything's linear, there's a cause and effect. And in fact, that's not true. We know that it's lateral. There's internal and external stresses, this push and pull on systems all the time. It's not just a linear effect. The idea that we really can't preserve a landscape, right? We can protect a landscape. We might be able to conserve a landscape, but we can't preserve a landscape. We can't hold it in static perpetuity. That it's always this transforming, transitioning ecosystem, and we have to learn how to embrace that. That we're really not talking about objects, right? Objects are one thing, but it's really the processes and functions that happen that give shape to objects, that dictate where objects are and what they're doing there. And so process and function is something that we pay a great deal of attention and time to. And then this idea that everything's linear and there's spatial and temporal scales. And we like to think that, well, no, it's not really linear. Things are nested, like spatial and temporal scales are nested within one another. We can go up and down, but they all have influence and they all have direct relationship with those, higher nested and lower nested spatial and temporal scales as well. And so we really need to think about it as a dynamic system. So with those sort of paradigms in mind, I'll go over a couple of projects as we kind of think about them. We sort of have the both luxury and honor to be working throughout the country. And much of our work is up around the Great Lakes, and we're working throughout the Great Lakes, both in what was historically the Black Swamp area, which is sort of the northwest and section or northwest region of Ohio, and northeast region of Indiana. Once was one of the largest freshwater swamp areas in the United States. This is actually over in this project is outside of that region, but it's in an area called Beaver Creek in Chardon, Ohio, where agriculture is really, had 150 years of imprinting itself on the landscape, and many of the tributaries and many of the stream systems there were ditched and lined in order to provide flat, open land for agriculture. And Beaver Creek was one of those areas that flowed into a natural lake there. And we were asked to come in both by the state of Ohio and the local county here to really take a look at this and think about how we could enhance and restore biological diversity to this creek, and also enhance water quality. Much of this creek drains farmland, which then enters into a lake, and they're seeing all kinds of degradation of the lake because of that. So the idea here is how can we treat that water and treat it in a natural way using what we may call as natural-based solutions, but also really increase the habitat of the area as well. Much of our work is design oriented and construction oriented. We have the sort of this, what I would call transdisciplinary staff of ecologists and biologists and geomorphologists, but we also have landscape architects and ecological and water resource engineers and GIS analysts and planners. And so much of our projects are really looking at it from a multidisciplinary perspective, where we are able to sort of apply our skills from all the way from assessment through design and construction drawings to either actual construction or construction oversight. We do construction as well, which gives us sort of the opportunity to go out there and learn from what's working out in the field as we apply these different ecological principles to the field, and what's not working and how do we take that back and apply it to the next project. And in this project here, in terms of taking Beaver Creek and doing some of the hydrology and hydraulic modeling, looking at water quality, looking at soils, we're able to develop this sort of braided system, which historically we think was a braided system at one time, and take that aligned ditch creek and turn it back into this braided system where we're reintroducing a variety of different native riparian plants, some poles, some oxbows, and one of the other features that we add to a lot of our projects is wood. Wood's a huge element that we're losing quite a bit in a lot of our landscapes. It's a tendency for us to sort of clear out leaf litter and clear out wood and manicure the landscapes. And really, if we're thinking about carbon and removing carbon from the air, we need to be adding carbon back into the soil, and wood is one way to do that. So many of our projects are about reincorporating wood back into the landscapes that we work on. Also, another big consideration with all of our projects is working with the local communities, working with the local NGOs and other organizations that have a stake in the project, and getting out there. And not only, do we need to do some of this restoration work with some of the heavy equipment and the yellow iron that we call it, but also getting out there with the community to partake in the restoration. And that's really critically important in terms of getting people engaged. Even in this project, setting up these sort of analog beaver dams as a way to begin backing up water, using wood and using brush and using live, in this case, some bioengineering live branch layering to create some of those analog beaver dams to provide water quality enhancement and biodiversity. And so what we end up with is a system that begins to restore itself back to what existed prior, but also recognizing that there are different flow rates from a hydrology and hydraulic perspective, and also recognize that we're dealing with maybe a different sediment regime and different water quality parameters that we need to begin to incorporate in our projects. I think the other thing, recognizing that nature isn't static, that we also look at these projects that they'll evolve over time. And we fully expect in some areas where storm events or really high flows might create offshoots, might short circuits. Some of the meander bends that we have might create new pockets. And when we're able to deal with a landscape where we can allow that evolution to happen, that's something that we try to build in to our projects. Similarly, this is Red Horse Bend, which is in Fremont, Ohio. And not to take you through all the sort of iterations of it going from design to construction, but the image on the left was prior. The image on the right is after we finished the design and construction over about a 2 to 3 year period. And again, it's taking sort of what was once a riparian floodplain here, begin to reconnect the river back to the floodplain, begin to add habitat back to the floodplain, and a chance for water and floodwaters to assimilate, to raise the groundwater table, and to begin removing some of the nutrients and other heavy metals and hydrocarbons from the water column. So it's sort of a win-win-win in a lot of different perspectives there. These are just some of the close-up photos of after just even 2 years of finishing these projects. And the idea here is that we are trying to jumpstart those ecological processes and functions that I talked about. You know, structure for us is important, but really jumpstarting those ecological processes and functions are even more important. And that's something we try to strive for on all the projects that we work in. And in fact, one of the other projects that we recently completed for Cleveland Metro Parks in Ohio, there was some research done on it. We love when there's research done on our projects. We were able to do some research when we partner with some academic institutions, and there are other times where academic or research institutions go out and independently do research on our projects. This is a golf course that we converted into wetlands and a natural park for Cleveland Metro Parks about 4 or 5 years ago. There was some research done on its ability to enhance water quality, and what they found was that this stream restoration lowered phosphorus levels by an average of 0.31 milligrams per liter, which is huge, which many times what we're striving for in a lot of the green infrastructure projects in urban areas where we have a pretty good idea of removing nitrogen, phosphorus is always one that's a bit of a challenge. And now this research is coming out that if we use this kind of nature-based approach and we really incorporate a complexity of different types of plant material and soils and wood into our systems, the more complex, the better, that we can begin to reduce some of these nutrient loadings that we have in some of our systems. So on the other end, we do a lot of work on coastal communities as well. And in fact, you know, being here in Charleston, South Carolina, I think we're, let's see, we get hurricanes here, we get sea level rise here, we get tornadoes here, and we have earthquakes in Charleston. So we're sort of right at the epicenter of a lot of these major events here. And Charleston, the peninsula, if you've ever been here, you might know Charleston sits right on the confluence of the Ashley and Cooper River, which makes its way out to the Atlantic Ocean. So there's a direct viewshed and direct sort of link right at the head of the peninsula of Charleston, right out to the Atlantic Ocean. And that gets battered by storms. The last hurricane on record was Hurricane Hugo back in 1989, which pretty much decimated the area. Over the past 5 years, I think I've had to evacuate 3 times from Charleston and go inland. My family and I, because of hurricanes here, and based on sea level rise projections and hurricane and climate change, we're expecting more. So the city of Charleston is this peninsula that you see here on the right with that little bullseye there. This is the current coast. This is a projection of 4 feet of sea level rise, and you can see the blue creeping up into the peninsula. Probably a good 20% of the peninsula would be underwater with a 4-foot sea level rise. With a 6-foot sea level rise, almost 2/3 of the peninsula would be underwater. So it's very flat, it's very low lying, and it's very vulnerable to sea level rise. The other thing is it's very vulnerable to storm surge protection. Again, that peninsula is there in the middle of the slide, red representing the worst areas for storm surge, yellow next, blue further down, but you can see that the peninsula of Charleston outlined in the yellow with some blue in the middle. A good 80% of the city can be affected by storm surge, even just from a Category 2 hurricane. And so again, it's not only vulnerable to sea level rise, but also storm surge happening. So the Corps of Engineers has come up with this idea that they want to put a wall around Charleston, as it's outlined in yellow on the left. The red area is their study area. They calculated that a wall approximately 12 feet above tide, 7.8 miles long, could provide storm surge protection and also help provide protection from sea level rise. Again, for those of you that have been to Charleston, imagining a 12-foot high wall around the peninsula would completely alter the whole urban landscape of Charleston, not to mention its connection with these rivers and connection with the water and the ocean out here. The other issue that Charleston suffers with quite a bit is just rain events. And as rain intensity begins to increase, both in frequency and intensity, Charleston floods from the interior. So not only are they susceptible to flooding from the exterior, they get a lot of flooding from the interior, and it doesn't drain well when there's high tides, and we get a lot of water sitting there. The Corps of Engineers wall, while it will address sea level rise and address storm surge, it will not address stormwater within the peninsula itself. These are just some photographs. We went out and took some photos of what a 12-foot wall would look like if you were to superimpose it, in this case, along the perimeter of the Ashley River in the city here. And in fact, some other folks, Jared Bramble from HDR also went out and did his own sort of photo study of what a 12-foot wall or 12-foot high elevation wall would do to the city in terms of cutting it off from its context with the water. It would be quite devastating for the overall sort of cultural and contextual design of the city of Charleston. One of the things that we're fighting with the Corps of Engineers, or dealing with, I should say, is that based on their congressional mandate, they only can look at certain costs and certain benefits. And when they do their cost benefit analysis, they're pretty restricted based on that. So they're looking at mostly economic costs, right? And property costs and what they'll protect. What's missing from their equation when they develop these different solutions is they're missing the idea of what's going to happen to biodiversity, what's going to happen to ecosystem services, how are environmental justice issues being addressed, what's happening to stormwater inside the peninsula, what about livability, what about the urban fabric, what about tourism. And none of these are really taken into effect when the Corps does their cost benefit analysis. And in fact, most of these are left for the external sponsor, in this case, the city of Charleston, to deal with. And so while the Corps will bring some money and bring some expertise and engineering to the project, there's a lot left on the table that the local sponsor needs to pick up. So one of the things that Biohabitats did during the COVID last year is that in response to the Corps of Engineers wall, we decided to get a group of like-minded firms together and think about what it would be to re-envision or reimagine what this wall would be if we were to think about all those other things that the Corps is leaving out. And so we came up with some quick core principles of thinking about viewing water holistically, that this idea of protecting Charleston needs to be grounded in Charleston. It's unique to the place. There was some really interesting collaboration done with the Dutch about 2 or 3 years ago, which was termed the Dutch Dialogues with the city of Charleston. And they came up with some great ideas and worked with the community on ways that you could introduce nature-based approaches and contextual design to this. So again, we thought about how we could align this idea with the Dutch Dialogues. It's really about layers, that this all doesn't have to be done at once. It could be done in layers, and it could be done in layers that really, again, reinforce the cultural and environmental and ecological aspects of the city, and that it needs to be equitable. It can't just be looking at, at property that has a high value, that we need to be looking at all property, all communities, all people within Charleston, and it needs to have that kind of lens put on it. So we got on our bikes, we went around and spent a couple days in Charleston mapping and characterizing this area. We did this all pro bono as a way to sort of help the city of Charleston out. Plus, at that time, back in May and June of last year, when COVID hit, we were all kind of wondering what was going to happen. So we had a little bit of time on our hands. And it was a lot of fun. And we went out and basically created our own design workshop and design charrette to do this. Probably know that there's a lot of this sort of resiliency planning has been done around the country, certainly Rebuild by Design in New York City, the living breakwaters. We've had a chance to work with SCAPE on that. The Big U is another lower Manhattan project that's being considered in terms of the lower Battery area and where Wall Street is about protecting New York City. In San Francisco Bay, there's the Bay Area Challenge. We worked with Methuen out of San Francisco and Seattle on that project and came up with ways of protecting some of the communities and some of the communities at risk around San Francisco Bay in terms of introducing nature-based solutions. So there's a lot of precedents out there already that people and firms and communities have been doing. Also, the Corps of Engineers has their own engineering with nature. Dr. Todd Bridges started that up about 10 years ago. And now they have podcasts out there. If you're interested in listening, there's a manual out there now on engineering with nature, but it's all about taking environmentally sound and nature-based solutions and applying them to the landscape as a way to deal with climate change and storm surge and sea level rise. And so all these were used as sort of precedents and tools as we began thinking about this. And what we did is we came up with this overall idea that not only did we need to think about the perimeter of Charleston, but we need to be thinking about all the stormwater within Charleston, thinking about it as what we sort of termed one water. How could we do this in a coordinated way that actually builds on the contextual, social, cultural aspects of Charleston and builds on the ecological attributes of Charleston as well. So we came up with a list of perimeter strategies that we would use, really focusing on nature-based solutions. We came up with some ideas of water in the city and these ideas of stormwater corridors and sort of put them all together to develop a plan that provided that storm surge protection, provides overall long-term sea level rise protection, but does it in a way, again, that's really, I think, transformative and connected, and that it all, again, reinforces that sort of this special place that makes Charleston what it is. Some of the ideas that have been tried and tested, they're not necessarily new. The idea of living shorelines, either oysters and oyster reefs are still rather healthy and pretty robust in the Charleston area. So how can we begin to build even more to help dampen storm surges? How can we take some of the hardened shorelines and create habitat along those, or protect some of the existing wetlands that are already along parts of the shoreline of Charleston? We looked at this idea of horizontal levees, this idea that if we can create these levees that have a horizontal slope of maybe 20 to 1, 30 to 1, 50 to 1 instead of 2 to 1, that over time, as sea level rise happens, marsh migrates upslope. So we're not losing that habitat. We may be losing some open space parkland, but we're still maintaining the habitat, that interface between the upland area and the lowland areas. And then we also thought about the inland stormwater and green infrastructure and how we could turn that into an amenity that provides both protection and provides ways for this stormwater to drain out of the city, but done in an environmentally sensitive way that enhances water quality and enhances biodiversity. And then finally, the Corps was proposing a rock structure, a breakwater off the point of Charleston. And we thought, there's a lot of precedent out there already about creating living breakwaters. And certainly we could do that in Charleston too. And in fact, this point in Charleston was once known as Oyster Point. So the whole idea of incorporating a breakwater into oyster reefs and marshland seemed pretty obvious to us. And so we're going back to the Corps of Engineers. We presented all these concepts to them, and they're going through a second stage of looking at different ways of taking that wall and maybe incorporating some of these. And we'll continue to work with the Corps as they move forward along with this process here. The other big thing was diversity and inclusion and equity. The proposed core wall stopped. It really the upper 1/3 of the peninsula, where there's a lot of vulnerable communities further up the peninsula. And so the idea there is that how can we provide long-term protection for those vulnerable communities? Because we feel that spending the money and doing that in those areas is just as valuable as doing it in the rest of Charleston as well. So we've come up with ideas and plans to do that too. So imagine the wall. It's a website. So if you want to just jump on and see some of this and additional ideas that we have, certainly take a peek. Our team of design works out of Charleston, One Architecture out of New York City, and ATM, which is a nationwide firm in coastal engineering, really provided a lot of great ideas and collaboration with us as we went through this process. So, some of the other paradigms that we begin to look at is this idea of where we are, again, site-based versus place-based, less is more versus biologically complex, being reactive versus we really need to be multi-active. And instead of thinking about it as engineered and designed, we like to think about things as evolving, self-organizing, and self-maintaining. And if we can, put a little engineering design in it, but allow it to evolve and self-organize and self-maintain over time, then we really believe we're doing our job. In New York City, we had the pleasure of working with Olin Partnership out of Philadelphia on Pier 26. And as Hudson River Trust looked at turning this pier into a recreational pier, Olin came to us and said, we really want to do this living classrooms wetlands out at the end of the pier. So it's really thinking about restoration from a novel standpoint, an urban novel standpoint. What does that mean? And could we even get wetlands, tidal wetlands, to grow and be resilient out at the end of this pier here? Fun project. What we were really focused on, again, first and foremost, is the biodiversity that we could create in this very urban environment, given that we're right on the water's edge, and we're dealing with not only sort of a novel woodland and forest and upland grassland, but we started to think about maritime shrubs, and then we're into the tidal marsh and subtidal zone, and how could we begin to increase habitat throughout there. This is a photograph of the recently completed project. You can see some of these wetlands down here. These wetlands are designed in a way that they get flooded during high tide, get drained during low tide, so they act as tidal wetlands. The other thing that we did was we created these rock tide pools here. And look, we don't know if these wetlands are going to survive overall in the long run. And so these wetlands are actually all built above rock tide pools underneath them. So if for whatever reason we find that the environment is too harsh and these wetlands don't survive in the long run, we do have sort of this rocky escarpment out here that provides these tide pools, that provides its own unique habitat as well. So we're really thinking about this from a resilience standpoint and a long-term standpoint. We also designed this for sea level rise, thinking about sloping back up these wetlands in a way that over time, maybe the lower part or outer edge of the wetlands would be flooded out, but it would give time for the middle and back ends to become more robust and be able to withstand some of the tides as they begin to move sort of upslope there. We get involved in a lot of projects, not only in urban environments, but in rural environments. And we are lucky enough to be working out in the Pacific Northwest, where salmon are a really big deal. We're seeing salmon are on the rare, threatened, and endangered species list. And there's a lot of effort underway, both in Washington and Oregon and Northern California, to begin restoring salmon habitat, much like there is in the East Coast and in New England area as well. And we get involved in a lot of these projects where we're going back in and we're adding wood back to these channels that have historically been cleared out for flood attenuation or other reasons. And so they're missing all the wood and woody debris that's normally found in these systems. And we get to work with municipalities and state agencies to design and actually install these big wood jams, wood log jams in these systems out here. And so what you're seeing on the left is a pit where we're going to begin building a big log jam where, just like a glacier, about 2/3 of it is underground, so it won't get scoured out, or as scouring happens, it provides habitat. And about 1/3 of it actually pokes its head above the ground and will be susceptible to flooding. A lot of these systems are in these big river valleys where we can't get heavy equipment down per se, or a lot of these big logs, so we have to helicopter them in. And so we work with different contractors there to provide that service to bring the logs in for us to build. These are actually our own crews building all these projects here. As I mentioned before, Biohabitats does design build. Here you can kind of see the progression of these wood jams that are being built, sort of like Lincoln Logs, where we're building all these. There's a rhyme and reason for how they're stacked and how they're placed. But in the end, this is what you see on the surface, and this is what salmon love. And when you get really high flows in these river systems, salmon need a place to hide out. They need a place where there's slack water, where there's potential food sources. And these kinds of log jams provide that type of habitat for them. And so we've been working throughout the Pacific West doing that type of work there. We also get involved in a lot of campus work. This is Georgia Tech in the middle of Atlanta. We've been working on a project there called their Eco Commons. And the idea here with Georgia Tech is they want to really, over the years, turn all their green space into an ecological commons. We've had the pleasure of working with Nelson Bird Wiltz, Thomas Wiltz on this project and his team, where they were the prime landscape architecture, and we were brought in to do all the ecological work and support for them. I think one of the great things here is we looked at everything from irrigation to planting to soils, soil amendments and maintenance treatment. And one of the things that we did here is we have this all outfitted with micro sensors and monitors. So we're able to monitor different aspects of the site as it evolves and develops over time. And we're able to use that information to help inform future phases of the Eco Commons. We've turned this into a living laboratory that Georgia Tech can use, both from an academic perspective, but also just from their physical plant and learning what works and what works out there. And what we've also looked at is a reference system, a control system on Georgia Tech, and then how the Eco Commons is doing. So we're setting this up as sort of an adaptive management research project to begin looking at things like carbon sequestration. How well does it filter water? How well does it avoid runoff and attenuate flood events? And so all of that is ongoing right now. We've got these different, as I mentioned, control sites and reference sites set up both within the campus and outside of the campus. In the Eco Commons, the first phase of the Eco Commons was just completed, just planted last year. And we're watching that as that evolves with all these micro sensors And we're also now working on the next phase of the Eco Commons and looking at expanding that throughout the whole campus. So it'll be a different aesthetic, a different way of thinking about a university campus. And the goal here is to convert all that sort of green space lawn into an ecological commons that really supports biodiversity and habitat and ecosystem function and process throughout the campus. And then I'll end real quickly with this work that we're doing. We recently completed with the City of Atlanta. The City of Atlanta came to us and said, you know, our population is growing from just under 500,000 today to probably over 1.2 million by 2040. We know the City of Atlanta is an urban sprawl city. We need to rethink how it's growing. We need to think about designing it for people. We need to think about designing it for nature, and we need to think about designing it for people in nature. So they took the tack that they need to come up with a transportation plan, a housing plan, a building plan, a economic plan, but they also said we need nature to be one of those pillars that we use in terms of how Atlanta is going to grow in the future. We were fortunate enough to get that project and began thinking about this as an urban ecology framework. We knew it had to be science-driven, place-based first and foremost. Second of all, this idea that it, you know, like with all cities and with all ecosystems, it really needs to be richly layered and intricately connected. And then it also needs to be inclusive, it needs to be literate, and it needs to be adaptive over time. And so those are sort of the core principles we used in developing this overall ecology framework for the entire city. I won't go through all the different data analysis categories that we looked at, but this just gives you an idea. When we start thinking about protection, we start thinking about equity, multifunctionality, and stewardship. Then we broke that down into different categories that you see on the right. And then we even took each one of those categories and thought about, well, how are we going to model that? What's important? What are the important attributes associated with each one of those categories from an ecological perspective? And what does that mean from an urban ecosystem perspective? Also, community involvement throughout the city was hugely important. We held many, many different community venues where we got the community to come out and tell us what they liked about nature in the city, what was missing, what was there, what needed to be enhanced, what scared them, what made it fun, where did we need to enhance or embellish nature in the city. What were the opportunities for preservation? What were the opportunities for protection? What were the risks associated with this, and thinking about environmental justice issues and how that was correlated to different neighborhoods and how that was going to impact the way we thought about ecology in the city of Atlanta. The one thing the city of Atlanta has, it's touted as having the highest tree cover canopy of any major city in the United States. Certainly that came to bear as we collected data on that, but we took that a bit further and said, okay, trees are good, but what's unique about the trees? You know, where is the uniqueness? What is important there? And when we think about trees, there's really only two big patches of forest left on Earth, the Amazon and the Congo. All the rest has edge effects, and those edge effects really impact biodiversity and habitat. And so certainly in urban areas where we have a lot of fragmentation and edges, we needed to be thinking about how could we increase patch size? How could we reconnect forest even in an urban environment? So that's what we began looking at in the city of Atlanta. We began looking at patch size. We began thinking about habitat and biodiversity. We thought about the regional connections of Atlanta outside and how could you connect or reinforce those regional connections throughout the city. And we ran some models. There's modeling out there where we can simulate how different species move across the landscape. And based on those attributes that we identified, we modeled how species move. And what this model shows you, that middle and right photograph or right image, the greener, the easier it is for species to move throughout the urban environment. The darker color brown is the harder it is. And so that automatically told us, in the southern part of Atlanta, there's still some pretty good corridors or potential corridors for species to move through. And so we really wanted to focus on making sure that we protected those, but also then begin looking at other parts of the city where we're void of that, of that kind of quality. We looked at community, we worked with the community on their vision of what this ecology framework could be. We melded that into sort of 4 future scenarios where we first looked at equity and access to make sure everybody had access and equity to green space and ecological processes and functions. We looked at it from a landscape ecology perspective. We looked at it from an equity and landscape ecology perspective. And then we sort of piled on the idea of living infrastructure to really create this richly layered, interconnected ecological framework for the city. And so we've developed this idea of Atlanta City Nature that's published. And again, you can look that up, but it's really an idea for really big cities to begin putting nature on par with all the other things that they look at from an economic and cultural development standpoint. And we hope that's sort of the way of the future, that while we need to be out in the wilds restoring nature, we also need to be in our urban areas doing the same thing as well. So I'll just leave it at that. The values that Biohabitats has here: revere wild nature, heal compassionately, practice wholeness, act with uncompromising integrity, and evolve to be the best, or what we come to work with and what we apply to every one of our projects. We do a lot of part of our mission of restore the earth and inspire ecological stewardship. The inspire part is we do a lot of outreach. We publish a quarterly newsletter called Leaf Litter. The last one was on dam removal, if you're interested, but we try to pick a topic that has to do with conservation or restoration or regenerative design. So I'd encourage you, if you're interested, to take a look at that. And I know I've spent a lot of time here, so it's late, but I'm happy to answer any questions or discuss anything that we talked about tonight. Thank you for your time and patience.
Keith, that was fantastic. There was, in 45 minutes to an hour, quite a bit that you covered there, and a lot of it really resonated with me. And I listened to another webinar last night thinking about, and the point of that was like trying to take advantage of every little opportunity that comes along. And you kind of covered it there at the end, talking about the patch network within Atlanta. And I think that might be one thing to think about for us is, the interconnectedness is so important, right? But we need to think about how at a site specific level, can we make the most of that one individual site as part of the broader kind of whole network, right?
Yeah, I really do. I think that's what I emphasize. This whole idea of fragmentation is a really huge issue. And I think as landscape architects, while we only have the luxury or liberty to work on the site that's given to us, we can advocate for making or reinforcing or protecting connections that go off-site, right? We did that. We worked for the city of Chapel Hill in North Carolina for UNC, and we looked at a new site for them, and we did sort of this landscape ecology perspective of the site, but we also went off-site and basically demonstrated to the city the regional connections they had through their riparian areas and how important they were. And, that spurred them to think about changing their zoning and their land use policies to make sure that they give priority and preference to protecting those kinds of corridors and patches. So I think that's really important.
So if people want to either, put video on and come off mute and either raise your hand or type some questions into the chat, we can spend a few minutes here at the end just trying to answer some of those. I know there was one one question that had come in from Christopher, and he asked Keith, how do map movements ease of plant movement in urban environment and related to fragmentation? I wonder if you could decipher that for us.
Yeah, I'll try to decipher that. I'm not quite sure. Certainly. So there, excuse me. There are models out there that model species movement. Certainly we can begin thinking about how plants may migrate over time based on climate change or based on either other anthropogenic impacts. And I still think we're sort of in the early stages of how that might work. But I can say in the case with the city of Atlanta, this was a sort of a light bulb that went off with everybody in terms of mapping that what we're really mapping is the resistance to species being able to move across the landscape, right? So the more, obviously, the more built up the landscape is, the more resistant it is for species to move. The less trees, the less vegetation, the more resistant it is for species to move. The same can be said for plants. The less habitat there is for plants to reseed or to move into, the more resistant it's going to be, right? So the more opportunity, the more green space, the more areas we can provide plants to volunteer and move into, and the less resistance we can provide, the better. Means a landscape that's not manicured. Sometimes that means a landscape that's evolving over time. Sometimes that means a landscape that might be full of invasive species to begin with that needs to be managed. I think all that needs to be taken into
but also if you're trying to protect target species that are sensitive, like the mountain lion, then bringing people into a space can be disruptive to them and prevent them from like thriving. And even this photo that's on the slide right now of, you know, there's a boardwalk, so you're not directly impacting, but just people and voices and walking through can make, you know, bird species flee, etc. So I'm kind of wondering how you have a voice in that during these projects, and
that's a great question. Yeah, Erica, that's a really good question, because I think one of the things that I've found in, you know, working with other landscape architects and civil engineers is that we have a tendency to try to over-program some of the spaces that we're dealing with. And you're absolutely right. There are places and spaces where really the preference should be given to habitat, and we should be staying out of, right? And, you know, even this boardwalk here is fragmenting this landscape to some degree. I do know where this is. This is in Four Hole Swamp outside of Charleston, and it's a nature center, and it's only going in a part way where the rest of the area is all protected, right? But that being said, I think that we need to be really sensitive about other species and their needs. And there are some areas that, you know, on a landscape scale that we need to just protect and not have formal paths into and out of. That doesn't mean people can't go in and out, whether they're hiking or backpacking or whatever. But I think we are doing a disservice in some degree by bringing people into too many places too often. And so there definitely needs to be a balance there. And it, you know, not only impacts with people, but impacts with lighting, right?
Yeah.
Light
Yeah.
pollution. Forest edge. So forest edge is a huge issue. Forest edge can penetrate in hundreds of feet into a forest, cause changes in microclimate, cause changes in soil and soil fertility, cause changes in what types of species would inhabit that area, cause changes in wind throw from trees and nutrient exchanges. And we don't see that because it's sort of an invisible processes that go on, but it has detrimental effects on habitat. So the more, again, going back to that whole fragmentation issue, the more we can keep canopy connected, the more we can reduce some of these paths in and out, being more sensitive and thoughtful on how we provide visual access or experiential access without having to access the whole site is really important.
Yeah.
Yep.
Great. Thanks.
Yeah.
Keith, another thing that came to my mind as you were talking kind of earlier on was you mentioned something about like preservation and kind of the ability of sites to continue to evolve, right? And, you know, across the country and especially here in Vermont, like preservation and land conservation is so important and such a critical aspect of, you know, kind of preserving the aesthetic and the character of place, but yet is that almost fighting this idea of allowing biodiversity to expand and letting landscapes evolve naturally the way that they want to, right? And so at what point does our kind of austere kind of, you know, town and state, you know, regulatory environment, is it working against us in a way, right? It's certainly protecting development, but might almost be limiting ourselves too.
Yeah, maybe so. You know, I think that, you know, most landscape architects, I think we practice in the urban suburban realm, right? And we want to do all these great things, and a lot of us are doing great things in terms of conserving nature and protecting ecosystems and what have you. I think there needs to be equal weight given to restoring landscapes for species first, as much as we are working in the urban suburban environment, right? There needs to be a balance there. And there needs to be a balance not only on where we do work, but there needs to be a balance. There needs to be sort of this sort of political, cultural, zoning, land use balance of protecting and conserving landscapes for species and for ecosystem processes, as much as there is a balance in terms of trying to integrate these kinds of concepts into urban and suburban areas as well. And sometimes I think we fall short, we being not only the profession, but society in general, at least in the US, where we're not spending enough time thinking about those wildways, those wildland networks, and what we need to do to protect those. Because I'm all for densifying cities and urban areas and incorporating novel ecosystems and trying to incorporate ecosystem services and functions, but we've got to be spending enough equal amount of time in our rural areas thinking about conservation and protection and rewilding and those kinds of things.
We have a couple other questions that came in, and Amy, yours is first. You can either read it or I can read it for you if you'd like. I'll read what Amy asked. She said, landscape scale conservation analysis seems to be founded on preserving forest blocks and their connectivity. Is there a similar landscape scale conservation analysis of riparian zone connectivity? Riparian zone protection seems to be very piecemeal, not considering cumulative impacts through a regional riparian habitat.
Yeah, that's interesting, because I would have almost said that we spend more of our time working on riparian connectivity and see that being more robust because it's in a floodplain, more or less, versus landscape connectivity. And what we're always trying to do is connect over top the watershed, one riparian area with another riparian area. And that seems to be the hurdle for us, right? Because that's where you develop, that's where all the farm fields are, that's where the, extraction happens, that sort of thing. So I think it's probably different in different areas of the country in terms of how strong conservation is in certain regions. Certainly, I'm sure conservation is hugely important in Vermont and other parts of New England. I know down in South Carolina, there's what's called the Ace Basin, which the Nature Conservancy, working with the Turner Foundation and others back in the 90s, bought up hundreds of thousands of acres of land in the low country of South Carolina to protect it, which is great, which don't necessarily follow all the riparian areas. I know that working in the Mid-Atlantic area, riparian areas are the areas that are protected. And what we're trying to do is protect the areas in between as well. So I think it just varies throughout the country and where sort of the emphasis is placed.
Well, and your discussion of Charleston kind of made me think about this too, where, there's a lot of planning that went around kind of the area directly around the city on the peninsula, but then there's all the waterway kind of upstream of that too, right?
Yeah. I mean, the city is just not the peninsula, it's also on the other sides of the river and the county, and they're like, what about us? We're susceptible to all this too. Why are you just putting a wall around Charleston?
Right.
So,
and impacting us more in the interim.
right.
Hannah, you turned your camera on. Is that because you wanted to say hello, or do you have a question?
I do have a question. Thank you, Keith, for your presentation. I was wondering if you had any thoughts about, balancing land use designation and public access. I'm thinking in terms of, in COVID times, people were flocking to national parks and all these places that got huge influxes of use and overuse, compaction, denigration of all kinds of habitats, and then people were turned away. And so obviously there's a balance between the social need and the need of the ecosystems there. But I was wondering if you had any thoughts about how you, or if you have any project history about, just the nomenclature of these spaces that we want to protect, biohabitats, ecosystems, versus letting people in, because it feels like, there's been such an imbalance. And I know of many places across the country that are really going to be kind of reeling from sort of the COVID overuse of these national public lands. And so how do you balance public land that should be designated as protected?
Yeah, I think it's so nuanced, right? To know where the critical habitat is on our public lands and making sure that we're protecting those areas first and foremost. But I think it's absolutely fabulous that people are getting out and exploring, learning, visiting the national parks and pocket parks and neighborhood parks and all that. I think that's absolutely great. We need more of that. It just needs to be done in a nuanced way, right? And so I think that unless we're, if we're just going about it where we don't have a sense of what species are out there, what kinds of life requisites they need from a habitat perspective, how do we protect that? And then how do we provide opportunities for people to engage with these ecosystems in a way that isn't going to compromise that critical habitat? That's what we need to be doing. And it's different in every area, and it's different with every ecosystem. Some ecosystems and some species are much more resilient than other species. And so there's no one size fits all on any of that, right? I think one of the things that we see is we see in a lot of plans where planners will designate an area and say, okay, that's going to be our open space, or that's going to be, we're going to set aside this area and that'll be our open space. And it's done more, I think, from a standpoint of convenience of how either the development will work or maybe some other factors, but rarely is it done in terms of looking at what do species need from a genetic perspective, from a long-term perspective to inhabit that habitat. And if we understand that a little better, whether it's a site that's going to be developed or whether it's a national park or whether it's a regional park, I think then we can begin thinking about how do we provide opportunities for people to be engaged on the site and give them those opportunities to penetrate, enjoy, visit those sites in a meaningful way. I don't have an overall, here's what you do, because it's so different in every area.
So many developers just check the box and say, yeah, we've added the 25-foot perimeter buffer as open space, and there it is, right? And what actual benefit does that bring to a project?
Yeah, I mean, we were doing work out in San Francisco Bay and looking at restoring some of the salt marshes out there, and they've done some studies on the levees and people walking on the levees and what that does in terms of impacts to birds that are either nesting, roosting, feeding, right? And some species, birds they didn't see any impact. They couldn't discern any impact. Those birds could care less whether you were there or not, right? Mm-hmm. Other birds, maybe like a clapper rail, which, are secretive in the first place. Other birds were either, they were flying away, or they were exhibiting some kind of behavior that wasn't their normal behavior or whatever. And so it is species specific, it's ecosystem specific, and it takes that kind of research and study to understand then what kinds of impacts you're having, and then how can you bring people in to either lessen or mitigate or avoid those impacts.
I think we got 2 questions left here, if you will indulge us. The first is from Sam. He typed in a question and he asked, could you speak to how your firm plans for anticipated species succession related to climate change in urban areas?
Yeah, I think there's 2 thoughts to that, right? And we don't have the answer. We're still learning or trying to figure it out. The first thought is just keep planting the native species that are native to the site now, and allow other species the opportunity to migrate in over periods of time if that happens, right? The other thought is assisted migration. Should you be planting species now that are on the outer edge of potential migration or movement into an area, thinking that because of climate change, they'll be more prevalent in the future, right? And I think we do a little bit of both. When we're thinking about more urban areas where replacing a street tree or replacing a tree in a park might be a little bit more problematic. We might hedge our bets a little and be looking at the edge to think about what species we plant there, where we have the luxury of allowing the site to evolve on its own over time. We might be sticking with more of an existing native palette and allowing those other species to migrate in over time. So it's a little bit of both. But there's still, I think, a lot of research that needs to be done. There's a bit of controversy associated with each one of those, in the scientific community. But we're all trying to learn and figure this out.
Sam, did you have a follow-up?
I guess I wonder, in terms of with sort of an assisting approach, I don't know, are there planting plans that are kind of packaged with the project? I think of your Georgia Tech project, and I suppose that is a university, like they have the wherewithal and you know, capacity to change their planting palette as the environment changes. But yeah, I don't know, are there like future scenario things put in, or just, you know, I suppose that's.
Yeah, in fact, at Georgia Tech, we discussed that. We discussed that a lot, but we went with pretty much native Southern Piedmont endemic to that region species, right? The folks at Georgia Tech are really in tune with the planting there and are keeping close watch on that. And the idea is that over time, if species begin to either die out and or they see other species begin to migrate in, like you said, sort of they have the luxury of changing that over time, whether that's 5 years, 20 years, 30 years, I don't know. It's hard to tell. But certainly keeping the eye on that. I think the other thing to keep an eye that we're seeing and we're beginning to deal with is this idea of invasion from disease and other invasive species that weren't prevalent or haven't been a problem in the past that are now becoming a problem because their range is expanding as well, right? And so those are things that we're beginning to think about and deal with. And if there are native species that are on the outside edge that are more resilient to these kinds of diseases that we might be seeing, or more resilient to allowing invasives to come in, then we might hedge our bets a little from that perspective.
Okay.
All right, last one.
Thank you.
We got Patricia, your friend Patricia, Keith. You still here, Patricia, to ask something?
Sure, I'm here. I don't know if
It's great to have you.
thanks. We had our hearing closed instead of continued, so that's
Oh, no.
no, it's finished.
Oh, good.
And they're gonna deliberate.
So I'm sitting here too watching, Keith. This is Jim.
So I don't know. We don't know what you said because we had to go to our hearing, but I just wanted to point out that the Convention on Biodiversity in September of this year posted a number of 75% of the planetary surface deeply altered by humanity. So one of the things I think is really interesting is the opportunity to address degraded systems rather than only conserve important and systems that should be natural systems that should be protected. And one of the terms I'm using these days is biocultural diversity, because I think it's about all the species, including humanity and all that we do. So I'm wondering how you're thinking about degraded places. I know you've done a bunch of stream channel work and other interesting stuff, but I think we have a lot of the planet that needs work that we've messed up.
Yeah, absolutely. And I did show some projects. I mean, you know, 3/4 of our work is ecological restoration work, right? Where we're doing that work outside the sort of purview of landscape architecture, civil engineering. You know, it is restoration work. And so that's something that we founded the firm on, and that's something that we're still heavily involved with throughout. And, you know, this idea of fire in the landscape, right? We're seeing the devastating consequences, especially out west of these regions burning because culturally they haven't been burned in 100, 200 years. And so a lot of the landscapes that we deal with, fire is a natural and cultural element of that landscape. And so this idea of cultural restoration or cultural ecological restoration is something that we work with quite a bit as well. The longleaf pine forest in the southeast, there was 90 million acres of longleaf pine, and now there's less than 2 million acres left of longleaf pine forest, and it's a fire adapted landscape. And we know that indigenous people set that landscape on fire for cultural reasons. And so I think there's a huge connection between restoring sort of the sort of cultural and ecological processes that happen on our landscape. I do think too that there are landscapes that for their own right, from a species perspective, need to be protected and conserved and restored for those species. Sort of maybe where the cultural influence is a lot less, right? It's a sliding scale of how much cultural influence there was on our historic ecosystems and how little there was. And I think we're still learning that and learning to find the balance of what that balance is to not only provide an protection and increase in biodiversity, but also do it in a way that supports the sort of ecological processes that we need to live. So.
Right. So the other thing that's interesting to me, you've had a lot of contributions that you've made to IUCN and the IUCN network. The process of protected areas and the different levels is actually kind of that sliding scale that you're talking about. So all the way over to the highest level of pure science and all the way down to parks and small preserved areas. The thing that's interesting on the Protected Planet website that I was researching a week ago is this new category called Other Effective Conservation Measures that is being added to the percentage of land on the planet saved. And with E.O. Wilson doing his 50% Earth tomorrow, I thought maybe you would make a comment about this whole move to 20%, 30%, 50% for the planet that's being talked about, which is very interesting when you weigh it against the fact that the Convention on Biodiversity is saying 75% of the planet messed up by humanity, perhaps some of it not messed. So there's all of this dialogue right now about how much do we need to conserve to have an impact on climate change and do more carbon sequestration and all of that.
Yeah, I think that the science is still evolving, Patricia. I think scientists would say that it is somewhere between 30 and 50% of our terrestrial and marine ecosystems that we need to protect, right? Or protect and restore.
And the Protected Planet right now says 19 and 17 or something like that.
Yeah, it might even be less than that. Yep. The other big issue that scientists are dealing with is where, right? It's one thing to say 30% or 50%, but where? And there's a lot of good research out there in terms of, where's the highest biodiversity? Where are we protecting all the different types of ecosystems, and to what degree? How resilient are certain ecosystems versus other ecosystems? So all that goes into play. So the idea of 30 by 30% of the earth and by 2030 is a sort of calculated way of eventually getting to 50%, right? And so the idea that we start with 30 by 30, and if we start making progress toward that, then hopefully beyond that, we can get to 50%. But it's somewhere in that sweet spot that we need to be in terms of protecting biodiversity and in terms of having any kind of impact on climate change.
Yeah, so thanks for that. And just to be a little clearer for the rest of the folks, you can look this up on Protected Planet and look at the maps of the planet, and that's a joint mapping effort with its various constraints and opportunities, and it's by IUCN and UNESCO World Conservation.
Correct. Yeah, very good. I belonged to IUCN for many, many years and went to their conventions and spoke on behalf of ecological restoration. It wasn't until about 10 years ago that they even began considering ecological restoration as part of their initiative. It was based solely on conservation before that. So it's really good that restoration is making a huge inroad and impact in the way they're thinking about, protecting and restoring ecosystems.
It's terrific.
Seems like if we've had 75% impact and we're trying to get to 50%, then the net way to get there is through restoration, because you certainly can't preserve enough to get to that.
Right. Yeah, absolutely. Restoration needs to be a critical component. Yep.
Keith, I feel like we could sit here all night and talk about a lot of this, but you've given us quite a bit of your time already. We all really appreciate it. It was very helpful and a great lecture, and always insightful. It was great to have you kind of virtually visit Vermont. I need to thank also Tony and Jeff from Reed Custom for their sponsorship of the chapter and from the event tonight. And I should have mentioned this at the beginning, but please go to VTASLA.org if you want to learn more about our chapter. And thank you all for attending and for the good, insightful questions as well.
Yeah, thank you all for having me. I thoroughly enjoyed it. Great questions, great dialogue. And as I said to Tom, I'll make this presentation available that you can post on the website. So
that would be fantastic. And we thank you for that.
Yep. All right.
Okay.
Good.
Thank you.
Have a great night, everyone. Thank you.
Great. Thank you.
Thanks.
Bye.